Removing surface defects from steel slabs prior to rolling is an intrinsic part of the steelmaking process, and scarfing, a process that removes the defects from the slab surfaces using a combination of gas and oxygen, still remains the most practical solution. As technology for steel manufacturing has changed, so has the technology of scarfing. The ingot root method of making slabs has given way to continuous casting. Continuous casting has significantly reduced defects on the slabs. Defects are fewer and not as deep. But many mills are still using large conventional machines to scarf the entire slab at a constant depth when it is no longer necessary. Since defects on continuous cast slabs are fewer, they require a more precise machine capable of scarfing at precise areas and depths to ensure all defects are removed, which also improves yield. So in most cases, large, costly conventional scarfing machines are being replaced by more efficient machines designed specifically for scarfing continuous cast slabs. One such machine is the robotic scarfing system from Indiana Flame Service, an affiliate of the Edward C. Levy Company, a corporation headquartered in Detroit, Michigan. Indiana Flame's robotic scarfing machine is designed specifically to condition slabs produced by a continuous casting machine. The robotic scarfing machine requires only one operator to control the torch and the back and forth motion of the slabs from a control cab. He can position the torch anywhere on the slab surface. The machine simply responds to the movement of the operator's arm, and the torch angle is controlled by a switch on the control arm. The back and forth speed of the scarfing car that holds the slab is controlled by a joystick. Metal removal is more precise because the operator can slow the car to remove deeper defects. When no defects are observed, the operator accelerates the scarfing car, thus removing minimal steel in non-affected areas. Again, this is a significant yield benefit. With a single pass, the robotic scarfing machine is capable of removing as little as 1 millimeter of steel in unaffected areas and as much as 8 millimeters in defective areas. From inside the cab, the operator has constant vision of the slab surface. An experienced and well-trained operator can observe defects in the scarfing bath and adjust the scarfing speed to ensure that all defects are removed. There are no requirements to pre-identify defects before they are scarfed. However, if required, the scarfing speeds can be preset to ensure a constant depth of removal across the full slab face. The robotic scarfing machine offers many other unique advantages. Scarfing can instantly begin anywhere on the slab surface. An injection of low melting point iron powder infused into the bath enables immediate ignition, and scarfing commences without preheating the slab, whether on the broad face or the edges. The machine is much quieter than earlier technology because it's housed in an enclosure, and it scarfs at a width between 200 millimeters to 600 millimeters of surface in a single pass. Because all the surfaces are not scarfed in a single operation, there's no need for massive electrostatic precipitators. The only thing needed for environmental compliance is a bag house. There's no need for high-volume water in washways either. Scarfing waste is simply granulated in troughs. The robotic scarfing machine does not require a massive foundation like the earlier technology. Its much lighter weight only requires a platform. And the robotic system costs less to maintain, and fault finding is relatively simple. A scarfing facility can be built in less than 10 months. The main components of the system include an environmentally engineered enclosure for the robotic scarfing machine and enough room for 2 scarfing cars, approximately 450 square meters. Because of the environmental requirement of zero emissions, all of the emissions are contained. This enclosure can be built outside of the main slab yard building if required, with only the scarfing cars taking up real estate. The roof of the enclosure houses the various machine controls, including the gas oxygen station and high-pressure water pump. Fumes are exhausted through ducts in the roof and transported to a bag house. The bag house is normally located outside of the slab yard. The bag house has stainless steel compartments to improve longevity and special bags capable of handling moist fumes and particulates. The dust is automatically placed in sealed transportation skips for simple removal. The scarfing machine rests on a platform. It's equipped with an operating computer for slab tracking, dual seats for operator training, oxygen and gas controls, and scarfing speed controls. Descaling sprays are located behind the torch so that all oxide is removed, presenting a bright surface for easy slab inspection after scarfing. All of the equipment is controlled by PLCs, including fault finding and diagnostic analysis. The availability of equipment that has been operating for 5 years still exceeds 98%. You'll need 2 scarfing cars, a slab flipping machine, which is located between the slab cars, a crane equipped with magnets. The crane is as key to the operation as the scarfing machine itself because, like all handling equipment, an efficient crane significantly influences the productivity of any facility. And a control room. When the slabs are first brought into the scarfing yard, they are cross-referenced and assigned a number for tracking throughout the scarfing process. The crane operator places a slab on one of the 2 scarfing cars. By remote control, he sends the slab into the scarfing enclosure. As the scarfing car enters the enclosure, the slab is tilted vertically so that the broad face of the slab faces the scarfing machine operator. At the same time, an articulated scale plow on the front of the car pushes the scarfing waste to a holding pad so it can be easily removed by a front end loader and recycled. The plow then automatically locks into a vertical position so that the blade is clear of the granulating water while the slab is being scarfed. The scarfing car then automatically returns to the scarfing position, and the car is now controlled by the scarfing machine operator. Before the operator begins scarfing, he records the slab identification number into the operating computer, and all required scarfing information is displayed. The operating computer records all of the parameters during scarfing, such as speed, torch angle, the time, date, and number of passes for identification and inspection purposes. A foot switch on the floor of the operating pulpit initiates the required scarfing oxygen. Low melting point iron powder is injected into the flame and instantaneous ignition is obtained. While the slab is being scarfed, a second slab is loaded onto the second car and it enters the enclosure. When the operator completes the first slab, he sends the car out of the enclosure and pivots to the second slab to commence scarfing. Outside of the enclosure, the crane operator removes the first slab and places it on the slab turning machine. As we speed up the video, you can see that he exchanges the scarf slab for another slab and places it on the scarfing car. At the same time, the slab turning machine flips the slab and the slab car enters the enclosure. Soon, the second slab car exits, and those slabs are exchanged. Once the slab is fully scarfed, it is moved to an inspection area. The slab is fully inspected and any small residual defects, if remaining, are removed using a manual torch as to guarantee the removal of all surface defects. The slab is then re-identified, the scheduling slab tracking system updated, and the slab is ready for rolling. Although robotic scarfing has been around for decades, the technology has evolved and improved with time. The new technology, owned exclusively by Indiana Flame, consists of a very low-pressure scarfing torch. This torch uses only 3-bar oxygen pressure compared to 10 or even 12-bar pressure with previous systems. The new technology produces a superior flat scarfing profile, better defect removal, and a much shallower line between scarfing passes. The manpower required to run the facility typically comprises of a crane operator, a scarfing machine operator, slab inspectors, a co-coordinator, and one mechanic for each operating turn. Indiana Flame provides a complete service facility design, all of the required capital investment, maintenance, operation, and quality assurance. When evaluating a scarfing solution, consider the benefits of this system compared to any other process. Less real estate required for the facility. The robotic scarfing facility is a compact unit. A quieter machine that conforms to all regulations regarding noise. No more complicated washways to build and maintain. Gone is the electrostatic precipitator and all maintenance costs. Guaranteed environmental controls for air particulates. Less ongoing maintenance costs with improved uptime. No capital investment required by the user. Indiana Flame can make the total investment and recapture the costs over a period of time. And above all, guaranteed defect removal with a minimum yield lost. On a 250 millimeter thick slab, typical overall yield loss is less than 1.5%, compared to over 3% with earlier technology, which is an enormous cost savings. For more information on scarfing and other unique proprietary systems for slab preparation, such as burless slab cutting and slitting, visit www.indianaFlame.com. edwardsclevy.com.